at the very end of 6.1. And we're talking about parabolas, quadratic functions. So this one says Natalie has 500 feet of fencing. She wants to construct a rectangular garden with 3 sides made from fencing and one of the sides from the side of a building. So like, let's say she's doing the community garden outside, right? And she wants to put a fence around it. So maybe there's bunnies getting into the community garden and they're eating everything. So she wants to do like a length of X there and a length of Y, and then this is a building. Okay, so she has 500 total feet, so that means that 500 is equal to X plus Y plus X. Olivia, this is a new one. All right, so it says, what are the dimensions of the largest garden that she can create? That's an area, right? So we're going to write the area equation. And our area of a rectangle is just length times width, so in this case it's X times Y. But right now, it doesn't look like a parabola, right? X times Y, that's not a parabola. But if I solve for Y, right, Y is equal to 500 minus 2X. You just subtract the 2 X's over. So if I replace Y with 500 minus 2X, right, then it is a parabola. So I have A equals X times 500 minus 2X. So it's 500X minus 2X squared. So if I wrote it in standard form, I'd have negative 2X squared plus 500X, and then plus 0 if you want to see what the C term is. So it's AX squared plus BX plus C, like we talked about yesterday. Okay, and that's a parabola. It's a parabola that goes downwards. So there has to be a max. Okay, and the way we find a max or a min with parabolas is we do our axis of symmetry, right? X equals negative b over 2a. And then we plug in. So I have x equals negative 500 over 2 times negative 2. So I get negative 500 over negative 4, which is 125. So I just found the length of the 2 sides, right? The 125. Yes? Yeah, it's positive. Positive 125. No, because it was a negative, like it's negative b over 2a, and then you had positive 500. Like a is negative 2, b is 500, and then c is 0. Okay. All right, so if you want to find what the other length is, right, the y value, then you just plug into this equation right here. So you have y is equal to 500 minus 2 times 125. So you get y equals 500 minus 250. So it's 250. So the questions are, what are the dimensions and what is the largest area? Okay, so your dimensions is 125 feet by 250. Oh, you guys you could have gotten a bonus point. You didn't see I left off a 0 there, 250. Okay, so 125 by 250. And then your area is whatever 125 times 250 is. So 125 times 250. You could also have plugged into your area equation, the 500x minus 2x squared.
31,250.
Mm-hmm. Yep, 31,250 square feet. Yep. So those are your answers. Okay, so anything that says maximize or minimize, if you have a story problem, it's going to be these parabolas, right? Eventually, like in calculus, you learn other things for finding, like, for cubic functions and things. But, like, in this class, it's just going to be a parabola. Okay, so you can hear maximum or minimum, you have a parabola. All right, so the next one, it says, Alex tosses his algebra notebook upward. He's very angry. I don't know. He does not like the 200 pages of hand-typed love. So he's going to throw it in the air with an initial velocity of 15 feet per second, which is actually very, very fast. So he's throwing it very fast from a height of 4 feet. Yeah, we should. With my notebooks, oh man, I would be so sad. Those Office Max people that like did it by hand, they would cry. All right, so the book has the equation h of t equals negative 16t squared plus 15t plus 4. Okay, the 15 has to do with the velocity, the initial velocity, and the 4 has to do with the initial height. Okay, so don't freak out when you see these. A lot of you guys, I guarantee on your 6.1 homework that I just walked around and collected, you left the last problem blank because there were words. I don't know what that's about. Like some of you guys are juniors at this point. Like, when are you going to finally do story problems?
Never.
Not just skip them. No, you should try them. So, like, in your homework it said you threw something from a height of 200 feet, right? And when you plugged in time 0, you got 200 feet. That's what the y-intercept was. It was the height of 200 feet. Like, it's the initial height. It's where you started from the top of a tower, 200 feet. Okay, so anyway. So it says, what is the book's maximum height? So this is the height equation. It's a parabola. It's a parabola that goes down. So there is a maximum to that. So we just do x equals negative b over 2a. But in this case, I don't have x. I have t. So I do t equals negative b over 2a. So I get negative 15 over 2 times negative 16, which is the lovely 15 over 32. I should have been nicer. All right, so 15 over 32, if you find what the decimal form is, it's just as lovely. 0.46875. And that's in seconds. It was time, right? It says where t is in seconds. So that's the first answer. It says, how long does it take the object to reach its maximum height? That's one of the answers. But then it said, well, what is the book's maximum height? So now we plug it in. So we plug it in to our formula. So I'm just going to do 15 over 32. And on your calculator, you can actually use the answer key, right, instead of putting in 0.46875 each time. In some of your calculators, you can just arrow up and grab that last thing. You do that as well. So I got 7.516, I'll round. And that's in feet. So that's your maximum height. So the other one I said round to 3 decimal places too. So we're going to say 0.469 seconds. But I didn't want to do that until after I used that number in the next step, right? So don't ever round until the very end of the problem. All right, so that was the last little bit of section 6.1. So you could have story problems. You're going to be okay with it. If it says maximize or minimize, you know what to do. All right, so 6.2 is on graphing. So let's flip to that. So solving quadratic equations by graphing. So it says sometimes it will be useful to find the x-intercepts of a function. So for instance, I'm sure you've seen this on Mythbusters. You guys like Mythbusters? We've talked about doing a J-term Mythbusters, which I think would be really fun. All right. We've talked about it a couple years ago. Mr. Crowley thought about doing it. We should convince him. All right. Yeah, so anyway, going back to this. So it says, for instance, if we throw a small object, so they always talk about a penny. If you throw a penny off the Empire State Building, it drops all the way to the ground, it could kill someone. That's the thing. Like it will be fast enough at the bottom that it will kill someone. However, Mythbusters debunked it because there's other things in physics that come into play. So one thing is like, for those of you that drive, Jake, can you put your computer away? Those of you that drive, how many of you guys drive in here? A couple of you. If you go past a semi, have you ever noticed this? Like as you're passing a semi, you kind of get sucked towards that semi. Like your car moves towards it a little bit. Right, that's actually involving something in physics where if you have a large mass and you have a small mass next to it, that small mass is like its gravitational pull kind of, it gets pulled towards that large mass. It's very weird. Okay, but that also, when you're driving, it also has to do with the air. Like if there's a lot of wind, it's a real windy day, and you go by the truck's blocking your wind, and all of a sudden you're like, whoa, I can go back over on this plane. All right, but anyway, so that's one thing. So if you have a really tiny penny, and you're throwing it along this huge building, what's going to happen to this penny is it's going to get sucked towards the building. Okay, it's going to end up like going along the side of the building. But the Empire State Building is also like, right? Isn't it shaped like this at the top? So, I mean, if you're throwing it from the very top, I think you'd have to throw it from like the side of the building, right? Okay, so anyway, but the terminal velocity, like how quickly it's traveling, is like insane. It's super fast. It's like a bullet in the end. Okay, so it's good that it gets sucked to the side of the building so someone isn't killed. Okay, so anyway, so it says the height of the object in feet would be given by this equation because the Empire State Building, actually, I don't know if that's right. So if we want to find when the ball hit the ground, we would need to find when the height is 0. These are the x-intercepts of the function. So it's going to be important to find when things hit the ground, when the height is equal to 0. Okay, so this is called the 0 of a function. So it says a value of the input x that makes the output f of x equal to 0. These are also called roots. or x-intercepts. So if I ask you for a root, an x-intercept, or a 0, it means the same thing. That can be very frustrating for people in the test because one problem I might say, find the root of the equation. And the next problem I might say, find the zeros of the equation. And then I might say, find the x-intercepts, right? So, same thing, right? So solutions to a quadratic equation could have 2 roots, 1 root, or no roots. Here's what's happening in the picture. One real solution means you have some kind of parabola. It comes down, it hits a height of 0, and it goes back up. Or you could also have one that's going down, right? If you have like something like this. So that would be one solution. 2 real solutions would be a parabola that crosses. It crosses twice. And no real solutions would be a parabola that doesn't cross at all, right? No solutions. So like I said, you could also have downwards parabolas. All right, so in these examples, it says find the zeros of the function. So I have f of x equals x squared plus 5x minus 6, and we're going to use a graph and a table. Okay. Yeah.
We didn't get the last one, the no real solution.
Oh, the no real solution is just the problem of those intersect. Okay, so we're going to use a graph. Okay, this is kind of like a guess and check method. You're just doing a t-table, you're getting lots of different values. I personally don't like guess and check. I like a more straightforward way. So there is another way to do this. Okay, but something that's going to help me with the guess and check method is to actually find the line of symmetry. That always helps on parabolas. Did you guys notice that with the homework where you're like, man, I'm glad I drew this line in. Now every time I draw 1 point, I have 2 points. All right, so negative b over 2a. So I have negative 5 over 2 times 1. I get negative 2.5. I was also very nice on your homework, and I didn't give you any decimals for your axis of symmetry. So negative 2.5 is just between negative 2 and negative 3. So if I'm doing a t-table, let's say I plug in 0. I would have negative 6. So 0, negative 6. 1, 2, 3, 4, 5, 6. All right, I know it's a parabola that's going to go upwards. So it's probably going to cross somewhere over here and over here. You guys see it? I have that 1 point kind of for reference, but it's going to be on both of those sides. So let's say I plug in 1 to see what happens. If I plug in 1, I have 1 squared plus 5 times 1 minus 6. I get 1 plus 5 is 6, minus 6 is 0. That's what I want. I want to get 0 out in the end. That means 1 is a 0. So 1 is an x-intercept, 1 comma 0. Okay, by symmetry, can you tell what the other answer is going to be? So, no, I go over 1, 2, 3 and a half. I need to go over 3 and a half again. So half, 1, 2, 3. It's got to be like right there. So what is that? 1, 2, 3, 4, 5, 6. So let's try it. Let's try 6. If I try 6, I get 6 squared plus, or sorry, not 6, negative 6. So if I try negative 6 squared, you've had 2 opportunities to get bonus points, guys. Just slacking today. It's a Friday, clearly, right? So I get 36 minus 30 minus 6. So I get 0 again. So we have something like that. I don't need to find where the vertex is. I just need to know where it's crossing the axis. So here and here. So my zeros are negative 6 and 1. That's what I was looking for, the zeros, yes. Why did I move over 6?
Like on the how did you know?
Because I knew from symmetry, like if one was crossing here and then I had an axis of symmetry, the other one has to be like exactly even on the other side. No, because the axis of symmetry was actually at negative 2.5. Right, so don't go by the axis, like the y-axis. Go by the axis. All right. Is there an easier way to do that? Has someone figured it out? Some of you are super smart. Jake, are you figuring this out? Or are you like, I know this. I know a way to find the zeros. Right? I'm saying 0 equals x squared plus 5x minus 6. How do I solve an equation that looks like that? You could factor, right? You could have done x minus, well, x plus 6 times x minus 1, and you would get x equals negative 6 and x equals 1. So why are we doing this then? Like, why are we doing get subtract? We can just factor. Sometimes they don't factor, right? So that's going to be unfortunate. And it's going to be like a decimal answer, or like something with a square root in it, right? So how do we do this? All right, so here's this next one. This one I think also factors. So could we do it by factoring? I'd have 0 equals, I can pull out a negative, so I'd have x squared minus 4x plus 4. And it factors into x minus 2 and x minus 2. That means x minus 2 is equal to 0. So x is equal to 2. But there's only one solution. Uh-huh.
Can we x minus 4?
Nope. Because then you'd have a middle term of 3.
Never mind.
Does that mean that's the bottom point? Like,
It is the bottom. Well, almost. It's not the bottom point. It's top point. Do you guys see it?
Yep.
It's negative. So let's say I didn't know to factor, and I had to do a factor tree. I would first start with my negative b over 2a. Or not a factor tree, what am I talking about? And I had to do a t-table. You got the chapter 5 in my head. Yes?
Oh, wait.
So from my original, my a is negative 1, my b is 4, my c is negative 4. So negative b over 2a would be negative 4 over 2 times negative 1. It would be 2, which makes sense. So then when you try to t-table, maybe you try 0 first. You'd be like, okay, 0, negative 4. 1, 2, 3, 4. And you'd be like, I know it's going downwards, so I'm going to have a point above that. And then maybe you would try 2. That's when you would have gotten 0 out. And then you'd be like, okay, but that's exactly on the axis. That means it goes back down. Does this make sense? So there's only one 0. Your 0 is just the number 2. I should have a math spelling bee someday. Zeros does not have an E here. A lot of people put an E there. Also, vertical is spelled A-L at the end. And asymptotes, you guys just have no idea how to spell asymptotes. So we'll get to that. All right, we should have a math spelling bee at the end of the year. All right. Yes.
This may sound like an odd question.
Uh-huh.
Why are they called zeros? Because that is kind of.
Because it's, yeah, a lot of people when they hear 0, like find the 0, they want to plug 0 in. That's not what you're doing. You're saying what x value gives me y equals 0. So you kind of are plugging 0 in, but you're plugging it in for the y value. It's like this was y equals whatever, and you're saying 0 equals. Does that kind of make sense? So it's plugging in 0 for the y. Just remember it's the x-intercept. X-intercept, you plug in 0 for the y. All right, next up. We're going to skip number 3. We'll go to number 4.
Should we just cross it out?
Yeah, you cross it out. So number 4, so it says solve x squared minus 6x plus 3 equals 0 by graphing. So what I'm really going to graph is the parabola x squared minus 6x plus 3. This is one that does not factor. Do you guys see that it does not factor?
Yeah.
Right, so this means it says if exact roots cannot be found, state the consecutive integers between which the roots are located. So I'm going to say, oh, my x-intercept is located between this number and this number. Okay. So let's do the negative b over 2a first. So I get negative 6, so 6 over 2 times 1. So I get x equals 3. And that's my axis of symmetry. So I draw that in. I'm speedy. Are you impressed with how quickly I draw on my dotted line? Is that what you're saying? Or you can't see the green? All right, so now I'm going to plug in some points. So if I do a t-table, and let's say I plug in 0, I would have 0 squared minus 6 times 0 plus 3, I'd get 3. So 0, 3. I know it's a problem that's going upward, so I'm definitely going to have something. I mean, don't draw this in, but I'm going to have something like that, right? Okay. I could also plug in something else and get 3 out. What number gives me 3? Oh, I already wrote it, 6. So 6 got me 3 because of the symmetry. Let's say I plug in 1. If you plug in 1, you get 1 minus 6 plus 3. So negative 5 plus 3, I get negative 2. It's down there. Okay, because of that, I have to have like a continuous function. I'm not going to like jump from one point to the other point without drawing a line, right? I have a parabola that's going to go through those 2 points, and then it's going to go back up. Okay. Do you see where it has to cross? It has to cross between 0 and 1. You get it? Because 0 was a positive number, and 1 gave a negative number, so it must cross the x-axis between 0 and 1 because of that. Okay, where's the other one going to be? If you use your symmetry? Yeah, between 5 and 6, right? Because if I plug in 5, I get negative 2 as well. So must cross between 5 and 6. So when I talk about my zeros, that's where they're located. My zeros, I have one between x equals 0 and x equals 1. And then one between 5 and 6. I'll just write 5 and 6 instead of x equals 5 and x equals 6. Does that make sense? It has to be there. Okay, so that's why we learned this method. So you learn the graphing method because sometimes they're not nice. Sometimes you can't factor. Like, how do you find where it crosses then? You do something like this. Yes? Okay. Eventually we'll do quadratic formula. Do you guys remember quadratic formula? Yeah. All right, so let's say we have this really tall bridge. Have you guys ever seen this bridge? It's the highest bridge in the U.S. It's called the Royal George Bridge. You've seen it? Yeah. It's in Colorado. Kind of connecting some mountains, you know. No big deal. And there's a river that goes underneath it.
Probably really tiny.
Yeah, probably. All right, yeah, you can't really tell from the picture how tall it is. Okay, but the deck of the bridge is 1,053 feet above the river below. Okay, so really tall. So suppose Garrett drops a marble over the railing from a height of 3 feet above the bridge deck. Okay, how long will it take for the marble to reach the surface of the water, assuming there's no air resistance? So we're going to use the formula h of t equals negative 16t squared plus h sub 0. Okay, whenever you have like an h sub 0, sorry, it's the blinds over there, loud. H sub 0 means initial height. Anything sub 0 always means initial, like at time 0. Yes. Yeah, so close, not plus 3, because we're already up really, really high. So we're going to have the 3 and the other number.
1,056.
Yeah, so it's going to end up being 1,056. But that really is kind of, like, it depends on if you're calling the river height 0 or if you're calling the bridge height 0. So I'm calling the river height 0, okay? And we want to find when it hits the river. So when it hits that height. Okay, this is not something that I have to factor. Okay, I can subtract my 1056 over and have negative 16t squared. And then I can divide by negative 16. I end up getting 66 is equal to t squared.
You keep saying
Negative 16.
Oh,
Mm-hmm. All right, and then I take the square root. Normally I'd write plus or minus, but I can't have a negative time. So I get the time as 8.124 seconds. Someone was like, why didn't you just make it nice so it came out to be 64, so it could be 8 seconds? I don't know, because the bridge is actually that high. Like, I didn't make up the numbers. Okay, so that's your answer. Mm-hmm.
How did you get 256?
I knew that it was, so like, basically here's the water. You have the bridge. So that's the 1053. That happened yesterday too. I feel like we have a ghost. And it opened the other one. I don't know why it's been doing that. Does it creep you out? All right, and then he's 3 feet, like he's dropping it from a height of 3 feet above that bridge. Okay, so Adam, yeah. All right, moving on. We're going to talk a little bit about 6.3 because it's on your homework. So, what time do we get out?
We
don't usually get out of 11 though. It's an eBay though.
Yeah, but it's a little bit 11.
Is it 11? Okay. All right, so 6 point, guys, you need to know this for your homework, so I pay attention. 6.3 is on factoring, so solving these equations by factoring. So you all probably remember this from Algebra 1. Like if you have something that looks like this, like x minus 2 times 2x plus 3 equals 0, it's called the zero product property. You would set each piece equal to 0, and you would solve each one, right? So you'd get x equals 2, and you'd get x equals, you would subtract the 3 over and then divide by 2. So negative 3 over 2. You guys remember that? Like as long as you have things factored, but it's set equal to 0, you can set each piece equal to 0. So that's what you're going to be doing in this section. So this first one, I have f of x equals x squared minus 6x plus 8. And it says find the zeros. Remember, that doesn't mean plug 0 in for x. It means plug in 0 for y. So you're going to factor. So you're going to have x minus 4 and x minus 2. And you're going to set each piece equal to 0. Most of you guys just do this stuff in your head. That's fine. You would get x equals 4 and x equals 2. No. The thing that causes people problems are things like number 2, which to me, this is like the easier one. Like you don't have to like factor in 2 sets of parentheses. If I have negative x squared plus 4x, I just pull out a GCF. Yeah, I have an x in common. And I'm actually going to pull out a negative x just because I don't like that negative. So I'm going to have negative x, and then I'm going to have x minus 4. See how if you multiply negative x back in, you get it. So I'm going to say negative x could equal 0, and x minus 4 could equal 0. So I get x equals 0, and I get x equals 4. So you're going to have a lot of things that you're going to be solving using factoring. So you're going to use things like the difference of 2 squares, right? The factoring skills you learned from last chapter, which you guys did awesome on the factoring portion. I was very impressed, like I said. So let's kind of skip forward, to 4b squared equals 1. So do you guys see that example? I don't know what page it's on. Okay, it says solve by factoring. I realize that you can divide by 4, you can take the square root, and so on. But if I'm going to solve by factoring, I'm going to get everything set equal to 0. And then I'm going to factor, so I'm going to have 2b plus 1 times 2b minus 1 equals 0. Oh yeah, you can't see. I don't know why my projector is like that. It already took me a long enough time to get them to move the projector, so I'm not going to complain. I'll just continue to pull things down. All right, so I have 2b plus 1 times 2b minus 1. So I'm going to have each one set equal to 0. So I'm going to get b equals negative 1/2, and I get b equals positive 1/2. Right? Add the 1, divide by 2. So even things like number 6, 8x squared minus 2x minus 3, if I write it in standard form. So I'm subtracting the 2x over, setting it equal to 0. We know how to factor that. That's what we just did chapter 5 on, right? So I'm going to have 4x and 2x. I'm going to need a 3 and a 1. Can you guys kind of see where your 3 and your 1 are going to go? 3 there. 6 and 4. Yeah. So I need negative 6 and positive 4 to make that negative 2. So I have 4x minus 3 equals 0, and I have 2x plus 1 equals 0. So I get x equals, I add the 3 over and then divide by the 4. I subtract the 1 over and then divide by the 2. Those are your 2 answers. So what it means is if you had a parabola, those would be the x-intercepts. Okay. Let me pass out your homework.